What does terawatt scale mean, and why do we want to scale there? So the amount of power we need to power the world is around 20 terawatts average power today. And if we want to do that with renewable energy, then we need to generate on the order of multiple tens of terawatts of power. And that's why we need to scale photovoltaics. Solar energy, the sunlight hitting the earth, is the most abundant source. And just tapping a small fraction of that is plenty enough to power us. But we need the devices to do that. But to do that, we need to produce a lot more solar. So in total, today, the total deployed solar amounts to around 1 terawatt. And we need to get towards 50 to 100 terawatts of total deployed solar to be able to power the world with solar energy. If we take a step back from perovskites and think about what do we want to achieve, what we want to achieve is more power per module, more power per square meter, per square kilometer, per hectare, per land use. So we need as little land as possible to produce our terawatts of solar electricity. So how do we increase the efficiency? There are multiple different ways, but one way is to stack cells on top of each other, which absorb different regions of the solar spectrum. Now, there are other materials than perovskites that can do this, but perovskite is quite unique because it's processed at relatively low temperature. It is itself made of very abundant materials that are easily sourced, and you can tune the band of sunlight that they absorb. For this multiple stacks of solar cells to increase the efficiency, each solar cell that's processed on top has to generate a higher voltage than the solar cell below. And perovskites, they're not quite unique, but they're almost unique in their ability to generate very high voltages when they just absorb, for instance, visible light, but not infrared light. There are other materials that can do this, but they are based on highly crystalline semiconductors that are grown under very stringent conditions. Perovskites can be processed very easily via solution or vapor deposition methods. They're polycrystalline, which means you don't need to make single crystals, and they're very inexpensive, but they deliver extremely high efficiency. Today, there's not another material that can do that. So that's why we're so excited by the prospect of